Right, so we're going to start with the linear. Okay, so linear simultaneous equation. Linear simultaneous equations. Okay, so we're going to say consider the diagram below. Okay, so here we have two lines that could represent some, natural phenomenon. And what we really want to do is to find the point where they meet. For some reason, we really want to find that point. Okay, let's say that this is someone traveling in that direction, someone is coming in this direction, and you really want to find the point where they will meet. Okay, at some point they will meet, and that's what we need to find. Okay, so we're going to say solving. So we're going to say solving this.
Do we use the triangles and stuff for this to find the distance? No, that's just the distance of it.
That's physics reasons.
Yeah.
That's not physics.
Yeah, but we're going to be doing stuff like that. Yeah. I know what you're saying. Yeah. Okay, solving this system is about finding the point x, y, where these two lines meet. That's it. Okay, so that is what we're going to be doing. From year 10, okay, we're going to say this. So when solving linear simultaneous equation, when we're solving a linear simultaneous equation, we did it in two different ways. Okay, there are other way you can do this, but that is something that you're going to learn at uni. Okay, so we do substitution, and elimination. Okay, so that is the one that we done in the past. Elimination and substitution. Right? Example. Okay, let's say that we have two lines. The equation of the first line is 2x plus y equal 3. So that is my equation 1. And let's say that we have a second equation. And let's say that that is equal to x minus, just say something, 3y equal 1. All right? And then they say, find the point xy where these two lines meet. Okay, that's what we're going to do. And we're going to do substitution. So, substitution. Okay, when you do substitution, you need to look at these two equations. Okay, that's how we do it. So you need to look at these two equations and choose the one that, in your opinion, looks simpler. Okay, sometimes, well, they look the same, so Still, you need to pick one of these two. Okay, which one do you want to use?
One.
Okay, the first one. All right, so we're going to call this, remember, 1, 2. You're going to label it that. And then we're going to say, okay, from 1. So this is going to be the structure of the substitution method. And it works the same all the time. So we're going to say from 1, we have that 2x plus y is equal to 3. Okay, that is what min choose. So we're going to start with that one. And then you're going to look at this equation again, and we're going to have to make x or y the subject. But then you're going to see which one is easier. Y. Okay, so we're going to make y the subject. All right. So we're going to say then y is equal to minus 2x plus 3. Or you can do 3 minus 2x, same thing. Okay? And we're going to call this equation 3. Okay, because we're going to refer to this later. All right. So let's see what we've done. So you look at these two equations, pick up the one that looks easier, okay, and you start with that one. And then you look at this equation again and see which one of these two variables is easier to have as a subject. And you can see that y is the easy one, so we make y the subject. Okay? And then this is where the name is coming from. We are going to substitute the value of y into the second one. Okay, that is where the name is coming from. So we're going to substitute into 2. Okay, so we're going to say sub into 2, meaning x minus 3y, which is minus 2x plus 3, that have to be equal to 1. Okay, can you see what I did? Emilia? Make sure that you do this, okay? And then the good thing about the substitution is that you start with 2 variables, but then you reduce the whole system to only 1 variable. Can you see that we have x and y, but now we have only x? Okay, that is what all these things is about. And then we're going to have x plus 6x minus 9 is equal to positive 1, right? And then we solve it. So you tell me what comes up to that.
Add 9.
So we're going to have 7x first is equal to, and then we're going to move this. Yeah. And then we're going to divide 10 by 7, and we're going to leave it like that. Okay, so that. Okay, so that is where these two lines are meeting. Okay, so we know that they meet when x equals 10 over 7, but I really want to find the y value. Okay, now we're going to come back to this equation here. Okay, so we're going to say from 3, so from 3, we have that y is equal to 2, negative 2, multiplied by x, but we already know the answer for x, which is 10 over 7, and then plus 3. Okay, Media, can you please tell me what the answer for that is? 1 over 7. All right. Okay, so I mean that finding the solution for equation like this is quite simple, especially if you are having only whole number. If you have fraction, it's the same. You get rid of the fraction first, and then you do what we just did. Okay, and then you have the answer. And then in conclusion, all we have to have a conclusion. Okay, so therefore you're going to say, therefore, line 1, this symbol means intersect. Okay, so it's the opposite to the union. Okay, so this is intersection. Okay, so we're going to say line 1 intercept line 2 is equal to the solution set, which is 1 point, 10, 7,17. All right, that's it. So what you're saying that if you sketch these two lines, they're going to meet, at that particular point.
Why do we need the curly brackets?
We use these, we call them braces. Okay, we use braces when dealing with sets. Okay, so in here, we're saying that the solution set is that point.
Why don't we use the other notation because we weren't sure?
Why don't we just...
Because in the other one, we were not talking about points. We're talking about, just line on the number line, yes.
So, do we still need just the normal brackets?
Yeah, here is always a point, and always we do point like that. Okay? Okay, so this is the x value and this is the y value. But do you understand this? Okay, so we're saying that line 1 will intersect line 2 at that particular point. That's it. Okay, do you remember this substitution business?
Yeah.
Yeah? Okay, so you reckon that you can do any question like this? Yes? Okay, let's see if you can do this one. Okay, so we're going to call this example 2. So let's say this is number 1. Okay, example 2. If you can do this by yourself, man, you're going to be so happy. All right, so I want you to do this one. Okay, line 1 is going to be the line 3x plus 2y equal 5. You can call that one. Line 2 is going to be 2x minus y equal -6. Okay, can you please do this in the exact way that we did that one? Okay, showing all the steps and writing all this from, okay, subbing to, yeah, I want you to do it this way. Ashton.